Hi everyone, we're going to discuss polar equations of conics with the focus at the pole and eccentricity E. And the eccentricity formula is E equals C over A. And remember, so let's look down here real quick. The eccentricity, if E is 1, the conic is a parabola. And if E is less than 1, the conic is an ellipse. And if E is greater than 1, the conic is a hyperbola. And eccentricity is basically the ratio of the distance between the directrix and its corresponding focus, or foci. So a circle has eccentricity 1. So basically we're comparing these three down here to a circle. Alright, so let's look at this at the top here. We have a standard form of polar equation of a conic, and we have R equals EP over 1 minus E cosine of theta. The rest are the same pretty much, except you have 2 cosines and 2 E's, or 2 sines. Alright, and we also have minus plus, plus minus here. So if we have cosine, let's look at the cosine here. If we have cosine, then the directrix is perpendicular to the polar axis. Alright? P is your distance units. Alright, if it's minus, like here, means to the left of the pole. If you have a plus, which is here, that means to the right of the pole. And again, P is the distance. Now, when you have sine, both of these are sine. Okay, that means the directrix is parallel to the polar axis. Okay, if it's plus, that means it's P units, there's your P, above the pole. And if it's minus here, it means it's P units below the pole. Okay, in this video, we're just going to familiarize ourselves with this equation and kind of do some algebra on some and just talk about the equations. In the next video, we will definitely, we're going to actually graph the equations and discuss each equation. Alright, so this one is just kind of looking at the form and making sure you know this information here. Alright, so let's go to the first one. We have R equals 1 over 1 plus cosine of theta. Now, just keep in mind, these have to be 1 to fit in our equation. So, we know that EP equals 1 here, because that's your EP thing. Our E, remember this follows the form 1 over 1 plus E cosine of theta. So basically our E is 1. That means our P is 1. Because you set these equals, so 1 times 1 is 1. So P is 1. And it satisfies this B part here. That means the directrix is perpendicular to the polar axis at a distance of 1 unit to the right of the pole. So that's how we're doing these. So let me write that down. So on this one we have the directrix is perpendicular to the polar axis. You know what that is. That's the x-axis. Okay? And there's my and. I use Boolean symbols there. And is 1 unit right of the pole. It makes sense because cosine is like your x, right? Cosine is like your x. Sine is like your y. So cosine x is right or left. Y is going to be above or below. So in this case, on this one here, our EP equals 3. Our E, there's a 1 here. Our E is 1. And so our P is 3. All right? It's a negative, and it's sine, so that means it's parallel. The directrix is parallel. Remember, sine is parallel to the polar axis. So it's parallel to the polar axis. And what's my P? It's 3, and it's 3 units below the pole. And remember what pole means. Pole is the origin. All right? So that's how we're going to do this. All right, now let's do a few more. In this case, our EP, well, first of all, on this one, this number here is not 1. And so I'm going to write this where it is 1. So when we rewrite this, I'm going to write this as 4 over 2. I'm pulling out a 1. So I have to write this as 3/2 sine of theta. Because 2 times 3/2 is 3. Now I can reduce 2 goes into 4 2 times. So now that's my new equation. So now that I have that, I know my EP equals 2. My E equals right here, 3/2. So now I need to know my P. And all I do is set that, substitute. My E is 3/2. So 3/2 P equals 2. Multiply both sides by 2/3. So my P is going to equal 4/3. Because that will cancel and you multiply there. All right. So my E is 3/2. So E is greater than 1. Therefore, it's a hyperbola. The other two, by the way, were parabolas. Because E was 1. I forgot to write that. So since it's greater than 1, it's a hyperbola. Remember, we're comparing it to a circle. It's E is the ratio between the distance to the distance of points to the directrix and its corresponding focus. So it's a hyperbola, and since it's sine, we're going to write it's parallel to the polar axis, again, which is the x-axis, and the P, I didn't even write the P down. Oh, yeah, I did. The P, write it in red, P is 4/3 units, and since this is negative, that means it's below the pole. All right? Okay, number 10, or this one here, it's number 10 on my sheet. We have, this is in form. There's a 1 there, so we're good. So EP equals 2. E equals 2. So when I substitute 2 into here, we get 2P equals 2. So P equals 1. Right? And E is 2. So since E is greater than 1, it's a hyperbola. Since it's cosine, we're going to say it's perpendicular. The directrix, I should have said directrix here. directrix is perpendicular, so I'm going to write it, to the polar axis. And my P is 1, so it's 1 unit to the left or right? To the right, because that's positive. To the right of the pole. Okay? Now save the harder ones for last. So we have 2 more to go. We have a cosine and a sine one. Notice that this is not 1. This isn't either. So basically, I'm going to rewrite this. Pull out a 4. So it's going to be 1 minus 2 over 4, which is actually 1/2 cos of theta. So also can rewrite this as 3 over 4. I'm just putting that on top. I'm moving that up there. Okay, so 1 minus 1/2 cosine of theta. Now basically what we have is EP equals 3/4, because that's there. My E is 1/2, so I have to find P. And P, I'm just going to substitute here, in here, 1/2. P equals 3/4. Multiply both sides by 2, and you get 6/4, which equals 3/2. That is multiply both sides by 2. So this is going to be 3/2. Now that we have this, we know that E is less than 1, so it's an ellipse. I know it's cosine, so the directrix is perpendicular to the polar axis. And I know it's minus, so I'm using my P here. So it is 3/2 unit to the left of the pole. Okay, so that's just the information. Let's do the last one. The last one I'm going to rewrite as well. This is not 1, so I'm going to rewrite that as 6 over 8 times 1 plus 2 over 8, which is 1/4, sine of theta. Alright, now I can reduce this to 3/4. 6 over 8 is 3/4. So you have 3/4. 1 plus 1/4 sine of theta. So to save room here, I'm going to write over in here. E is 1/4. EP, is 3/4. And when you plug that in, you're going to get P equals 3. Because 3 times 1/4 is 3/4. So I remember this part here is your EP. All right. Now let's talk about it. It's sine. First of all, EP, not EP, but E is less than 1, so it's an ellipse. All right. It's sine, so it means it's parallel. The directrix is parallel, I'll just do that, to the polar axis. And also that it is 3 units, because your P is 3. And is it going to be above, below, left, or right? Well, since it's sine, we're going up and down, so it's above or below. Since it's plus, it means it's above the pole. Okay? That's all. The next video, we'll get more into detail on this. This is just looking at the equations. Hope you enjoyed. Thank you and have a nice day. Bye-bye.